Okay, so we're looking at, I think, first of maybe 3 or 4 videos on partial fractions, and we're looking at case by case. So in this first case, the degree of the numerator, so the degree of the numerator, so if that was x squared, is less than the degree of the denominator. Okay, so that's an example of what we've got. Okay, copy that and come across. Okay, so we've got this first example, and that's x squared, so we've got a case 1, and we know from our partial fractions that we can break this part up into 2 parts. So we've got 9x minus 2 over x minus 3, x plus, oh sorry, 2x minus 1 could be broken up into 2 parts. Okay, so like if you're looking at backwards, this number by this number gives us the denominator, and a combination of a cross multiply will give us the 2x minus 1. And once we know what the a and b values are, then we'll separate the original question into 2 parts, and then often as not they'll turn into logs or some other type of function. Okay, so we've got excuse me, we've got the original equals 2 fractions, and obviously that times that will equal the same as that. So that means that a times 2x minus 1 plus b times x minus 3 is the new numerator, and the numerator equals 9x minus 2. And we don't have to worry about the denominators because the denominators are the same. Now you've got 2 choices here. We can expand out, which I'm going to do in this particular case, and I'll show you in a second way to do it. So we've got 2ax minus a plus bx minus 3b equals 9x minus 2. And then this is an x term, and this is an x term, and that's the x term. So I know that 2a plus b equals 9, and I know that minus a minus 3b equals minus 2, and they've all got minus signs, so I'm going to make it to a plus equals positive 2, because they're all minus signs, so I made them all plus signs. So then we'll just use simultaneous equations. So I'll change colour. I'm going to eliminate a. So from this equation, 2a plus 6b equals 4. And then those 2 equations I'm going to subtract. And I'm going to subtract uphill. So 2a minus 2a is nothing. 6 minus 1 is 5. 4 minus 9 is minus 5. So b equals minus 1. And then subbing in, b is minus 1, that's minus 3, becomes over there, so a ends up being positive 5. And so the original integral 9x minus 2 over those 2 brackets dx is now equal to the integral of a, which is 5, over x minus 3 plus b, bb, so it's minus 1 over 2x minus 1 dx. And then these are both going to be log functions. So the first one, the derivative is 1, so I've got 5, so it's 5 log to base e, so I won't put anything. And the derivative of 2x is 2, so I've got half minus a half log 2x minus 1, and then plus, that's minus 1 plus c. Strictly speaking, if you want to, and I think most books will, they'll combine these together. So that half, before you can't combine these 2 through the minus sign until you get rid of that half. So we've got 5 log x minus 3 minus log 2x minus 1 to the power of a half plus c. And now we can combine, oh actually that 5 has to go away, so that 5 goes to there. Sorry about that, we can't use log laws until we've got the coefficients away. And so the final answer is to the power of 5 over square roots of 2x minus 1 plus c. So don't forget, log laws can't apply until you get rid of coefficients. Now I'm not going to actually show you the second way of doing it until I show you another example. So that one there is pretty straightforward. The other ones get a little bit complicated. Come across when you're ready. Okay, so this time we've got 3 factors. X minus 1, x minus 2, 2x minus 3. So we're going to have 3 letters, x minus 1 plus b over x minus 2 plus c over 2x minus 3. So you can imagine if we're going to do the cross multiply method, A would end up having those x minus 2 and 2x minus 3 as its factors, as its other numbers. B would have x minus 1 and 2x minus 3. C would have that. So the bracket would actually, if you actually did the expansion, would get quite complicated. So we start off with doing it. So we've got A bracket x minus 2, 2x minus 3, plus B x minus 1, 2x minus 3, plus C x minus 1, x minus 2, and all those things multiply to 2x plus 3. Okay, but what we're not going to do is we're not going to expand out all these brackets and make it complicated. So what we're going to do is we're going to try to kill off brackets. So for instance, if I say let x equals 2, then 2 minus 2 is 0, 2 minus 2 is 0, so we've only got this bracket left. So we've got B, 2 minus 1 is 1, 2 2s are 4, 4 minus 3 is 1, so the two brackets end up going away, and then putting x equals 2 there, 2 2s are 4, 4 plus 3 is 7, so straight away we've got B equals 7. And then you have to just think about other numbers that make the other letters go away. So for instance, let x equals 1. So x equals 1 kills that bracket and kills that bracket, so the A bracket is still alive. So we've got A minus 1 and another minus 1, and then 2 times 1 plus 3 equals 5, and so we've got A equals minus 5, and then think about a number that makes 2x minus 3 go away. So we've got let x equal positive 3 on 2. Now this is a little bit harder. So we've got C times 1 1/2 minus 1 is a half, and then 1 1/2 minus 2 is minus a half, equals 2 times 1 1/2 is 3, 3 plus 3 is 6, and so we end up with, when you finish that off, C equals minus 24, a minus sign there, and so bang bang bang, so we end up with the integral 5 over x minus 1 plus 7 over x minus 2 minus 24 over 2x minus 3 dx. So the answer is 5. These are all base e, but I won't write them in. Minus 1 plus 7 log x minus 2 minus 12 log 2x minus 3. The derivative is 2, so we got 12 of them, plus c. So we'd probably leave it like that rather than trying to combine them. But strictly speaking, if they were to be a single, it'd be log x minus 1 to the 5, x minus 2 to the 7, divided by 2x minus 3 to the 12 plus c. Okay, so copy that and come across. I think got one more to go. So in this last one, we've got repeat factors. So what we have to do is we have to allow for the fact that the bracket, the denominator could have 1, 2, or 3 of these. So we end up with a, so the first part is 2x minus 1 plus b over x minus 2. Now, when you combine fractions to get that factor, we could have had a fraction with one of them, 2 of them, and 3 of them. Because if we had these as our fractions, we'd end up with that as our lowest common multiple. So we don't know that we don't have 1 or 2 or 3. We definitely have to have some combination that gets to 3, but we could have had 1 of them, 2 or 3 of them. Okay, so let's go next part. So we've got the denominator, and again we need to check it was a case 1. So x times x cubed is x to the 5. So the denominator, the numerator is less than the denominator, so it's a case 1. So we've got a, and we've got x minus 2, and we only need 3 of them to make up the first one. plus b. So b needs 2x minus 1, and it needs all the x minus 1s. And then c needs the 2x minus 1, x minus 2. Now it's got one of them, so it needs another 2 to make up to the 3. And d needs the 2x minus 1, the x minus 2. It's got 2 of them. The highest is 3, so it just needs another one. And the last one, e. E's already got 3 of them, so it just needs these 2 over here. Okay, so there's only 3 substitutions we can do. We let x equals 1, and a's dead, b's dead, c's dead, d's dead, and e's the only term left. So we end up with, where's the top line? So 4x plus 1 cubed. So that all equals 4x plus 1 cubed. So when x equals 1, 4 times 1 is 4. So we've got 5 equals e times 1 and minus 1. So e equals minus 5. Let x equal 2. We'll kill off a, b's alive, c's dead, d's dead, and e's dead. So we're trying to survive on b. 2 cubed is 8, 8 fours are 32, plus 1 is 33, equals b. B. 2 twos are 4, minus 1 is 3, so the first bracket is a 3. 2 minus 1 is 1, 1 cubed is 1. So b equals 3 into 33 goes 11. Let x equal a half, and that will kill off all the 2x minus 1s. The only bracket that doesn't die is the a. A half cubed is an eighth. 4 times 8 is a half, so you end up with 1.5, and the only bracket alive is the a bracket. So a half minus 2 is minus 1.5. A half minus 1 is minus a half to the 3 is minus 1/8. And when you tidy that up, a equals 8. Now we've got no other letters left that we can substitute in. So to find the other ones, the other 3 letters, we've got 2 more to go, C and D. What we do is we equate like terms. Okay. So for the power 4 term, there is no power 4 term, but x times x cubed, so a is going to have a power 4, b is going to have a power 4, c is going to have a power 4, d is going to have a power 4. So they're all going to have, except with the exception of e. E's the only, e doesn't have it. Actually, going back, d doesn't have it because that's got x and x and x. So x cubed, x cubed, x squared is x4. So the a, the b, and the c are all got power 4s, but there is no power 4 in the answer. So 0 will be the power 4, but we've got 1 times 1 cubed times a, so we've got a as a power 4. In the b's, we've got 1 cubed is 1 times 2, so we've got 2 b's. And for the c term, we've got 2 times 1 is 2, so we've got 2 c's. And then we know from our previous work that a is 8, so 0 equals 8. B is 11, and C is what we're trying to find. So 2C equals negative 30, so C equals negative 15, so that's okay. And then to work out what the last one is, we could go to the constant. So the constant is 1, okay? And then working your way through the brackets to get the constant. So for instance, in the constants, we've got minus 1 cubed is minus 1 times minus 2 is plus 2. So for instance, we've got 2a. And if you work your way through the other ones, you should find that you've got a single b, a 2c, a 2d, and a 2e. So just go through and make sure you've still got all those, and then we make the substitutions. So we've got 1 equals 16 plus 11 minus 30 minus 2d that we're trying to find minus 10, so that 2d equals negative 14, d equals minus 7. And so when you go back to the final part of the question, we've got the integral of 8 over 2x minus 1 plus 11 over x minus 2 minus 15 over x minus 1 minus 7 over x minus 1 squared minus 5 over x minus 1 cubed dx. And so this first one turns into 4 log 2x minus 1. Don't forget, these are all log e's. The next one is 11 log x minus 2. Next one is minus 15 log x minus 1. Now these last couple don't turn into logs. So these are linear relationships, so we're going to add 1 to the power and divide by the power. And so this one here is going to turn into just positive 7 over x minus 1. And this one here, when you add 1 to the power and divide by the power, you end up with 5 over 2x minus 1 to the power of 2, and then plus c. So you might have to just review how to do normal integration with linear functions. So it's 5x minus 1 to the power of minus 3. Okay, that's the idea. And then you add 1 to the power and then divide by the new power, things like that. All right, and that's it. That was a long video. Apologies, but there were a lot of examples to cover. Okay, bye.